Hey guys, welcome to Safi Mixed. In this video, I want to prove graphically that vector addition is associative. That is, I want to prove this relation for vectors. So I can take any three vectors A, B, C arbitrary in arbitrary direction. So let me consider that vector A is in this direction and that is the magnitude of vector A. Then I consider vector B to be in this direction. This is the representative line of vector B, and then I consider vector C to be in this direction. Right? These are just arbitrary direction and the magnitudes are arbitrary, but we want to prove that law. So what I do, I want to add these vectors through the head to tail rule, and we have learned that the order of adding these vectors is not important. That's we have already discussed in one of our videos. So I can take vector A first to draw it in this direction. Then I put the tail of vector B on the head of vector A and draw it in its own direction like this one. And then I put vector C over the head of vector B to draw it in its own direction. Let's say this is the direction of C. So this is vector B and this is vector C. Now I added the three vectors and I want to prove this relation using this addition. And first I need to find a resultant vector of vector A and B, and that I can do by joining the tail of vector A with the head of vector B. So this is the resultant vector A plus B of the two vectors A and B. Now if I join the tail of vector A plus B with the head of vector C, this one, and I call this vector D, then following the head to tail rule, this vector plus this vector is equal to D. So I can write that D equals A plus B plus C. Okay, I can write this relation from this addition. Now I want to find the resultant vector of B and C, B plus C, and that I can do by joining the tail of vector B with the head of vector C. Then this vector is in fact equal to B plus C, right? This is the resultant of vector B and C through the head to tail rule. And if I join the tail of vector A, which is also the tail of A plus B, with the head of vector B plus C, which is also the head of vector C, then following this way, A plus B plus C is in fact D. So I can also write D as vector A plus vector BC. I can write that B plus C. Now we have two relations for vector D, and obviously I can compare them with each other. So if I compare the right sides of these two relations, I can write A plus B plus C. This one must equal this thing, so I can write A plus B plus C, which is this one relation, although written in inverted form. So I can write that like by writing this to the left, I can also write it like A plus B plus C equals, then this side A plus B plus C, which is the required relation. So vector addition is associative, that is, this relation holds for vector addition. And then thanks for watching.